Your doubts now, beta?
Sir, can you repeat this one more time, sir? This diagram, this polar distance, true altitude and latitude. Just one more time, please, sir.
Beta, which part you have doubt?
Same, sir. This after this true altitude, we will get the zenith distance TZD. Then you said Z latitude explanation of latitude and the polar distance, sir.
Okay, beta. P to Q is 90 degrees. Q to Z is the latitude. So P to Z is 90 minus latitude, also known as at the yellow colors,
Okay.
right, beta? And if you come to the
North
celestial,
celestial pole to equinoctial, that will be 90 from pole to Q.
that's right,
Okay,
P to
sir.
Q will be 90.
The Chinese. Yes, sir.
Okay,
And then third one is sir, polar distance.
okay.
Hmm.
Now you come to the celestial meridian. Celestial meridian is PXD to South Pole. This is the celestial meridian. Now from pole to point D, Papa to delta is 90 degrees. Pole to equinoctial is 90 degrees. And delta to X-ray is the declination of the body. Declination is basically how much north or south of the equinoctial a particular body is. So delta to X-ray is declination. This tells us P to X is 90 minus declination, also known as polar distance.
Okay, sir.
Okay, all right. चलें बेटा आगे.
Yes, sir. Hmm.
Very good. So we have understood the systems now. Now pay your attention. Next 10-15 minutes, we will be looking at the rational horizon diagram. Pay attention now. This is important.
Sir, one more doubt, sir.
Go ahead.
Sir, difference between true altitude and declination.
Okay, true altitude is with reference to the horizon, beta. How much above the horizon a particular body is. That is the true altitude, right? And declination is with respect to the equinoctial. How much north or south of the equinoctial a particular body is.
Yes, sir.
Okay,
Sir, so basically, declination is equivalent to the latitude on Earth.
that's right, beta.
And what about meridian, sir? What is equivalent to meridians?
GHA, beta. GHA represents the meridians on the earth.
Okay, sir, copy that. Thanks, sir.
Sir,
Okay.
for this zenith distance, we are measuring from zenith and rational horizon. Correct, sir?
No, zenith distance is zenith to the body, beta.
Zenith to body. So this we are using in from sir this in celestial sphere we are measuring from zenith point to the rational horizon means
No, to
we
the
are
body.
using two things. Rational
Zenith to
horizon.
rational horizon will be 90 degrees, beta, always.
Yes,
Zenith
sir.
to horizon. Zenith to the body is the zenith distance.
Okay. And second thing for latitude, we are using celestial sphere, other side mean North Pole to between equinoctial.
That's right. That's for declination. We call it declination on the celestial sphere.
There are three things, no sir. One thing we are measuring from rational horizon to zenith, that is true altitude. Second thing we are measuring from equinoctial to again this pole, sir. So that is for polar distance or and third one we are using for latitude for polar. So again
Right. You are right, beta. There are three things, three parts.
three things and three different circle we are using. One is for equinoctial.
That's correct. That is right. Three circles we are using.
third, only in the which what will sell is celestial sphere. This last one for latitudes or P to Q, whatever point we are taking, sir.
Right.
Okay, sir, understood, sir. Thank you very much. This is more complicated, sir,
Okay.
before, but now it's understood, sir.
Oh, let's make it easy. Let's make it easy. We will remove the complication now. We will make a easy diagram. Let's make it.
No, sir, it's good, sir. At least all the things should be in front of us so we can find out the differences.
Okay, good. Very good. Now, having understood the understood the equinoctial system, then the horizon system, and we are now able to see the PZX triangle on the celestial sphere. So let's now try to convert this PZX triangle rational horizon plane. Now this diagram which you see on the screen right now is exactly the same diagram picked up from the last slide. All the things which are mentioned here we have already discussed. You see this PZX triangle here. It is the same PZX triangle. PZ side is the colat 90 minus latitude. ZX side is the true zenith distance, which is 90 minus true altitude. The side HX represent the altitude of the body. And the third side PX is the polar distance, which is equal to 90 minus declination. Now, it will be very difficult for us to make this kind of diagram. This is actually a 3D diagram represented on a plane surface. And for solving the questions which are based on the PZX triangle, if we need to make a diagram like this, it will be very, very difficult, hard, as well as time taking. Especially in the examination conditions, if you have to make this kind of diagram in every question, it will effort time. So to show all these things in a very simplified version, we can simplify this particular diagram by simply looking at it from a different angle or from a different perspective. Now, how do we look at it? Let us try to understand it now. First of all, you see, we are only interested in that part of the celestial sphere which is above the rational horizon. That means this particular part, which contains the PZX triangle also. This is the part which we are interested in. We are not interested in the bottom part of the celestial sphere that is below the rational horizon, because that in any case will not be visible to the observer. So we are not interested in this particular part. Now, how to have a perspective or angle so that this bottom part can be eliminated altogether and we are able to concentrate our attention to the top part. So for this, we visualize as if we are looking at the celestial sphere from top of the zenith. Right now, we are looking at the celestial sphere somewhere from this west point, somewhere from this angle we are looking at it. But assume for a moment that you are able to go up to the zenith. Let's say you have a rocket, except you sit in the rocket, it takes off and it goes vertically upwards. Now, if that rocket goes vertically upwards, eventually at one point of time, it is going to reach the zenith of the observer. Now, we don't stop at zenith. We take the rocket still further upwards. Now, let's assume that the rocket has reached up to here. So once we have reached up to here, now we look down below towards the celestial sphere. So we are outside the celestial sphere now, and we are on top of the zenith, and you can say we are having a bird's eye view on the celestial sphere from top of the zenith. Like you see, many of the shots are drones nowadays. So the drone flies high up in the sky and it takes a bottom picture, a aerial view. So that is what we are looking at it. So right now our eye, or we are situated at where the laser pointer is, and we are looking down at the celestial sphere. Now, how does the celestial sphere appear? We will try to put it in a diagram on the right hand side of the screen. So in the blank portion now you will see how does the celestial sphere look from top of the zenith. Now first of all, the celestial sphere looking from top is going to look like a circle again. So it will appear like a circle as you see on the right hand side of the screen. Now when you are looking from top, you see this was the north point. The circle which we have made is basically the rational horizon of the observer. When you are looking from the top, the circumference of the celestial sphere will be the rational horizon of the observer. Anything which is below the rational horizon will not be visible to us. It will go on the far side of the celestial sphere. We will only be able to see what is on top of the rational horizon. So when we look at the celestial sphere, the circumference of the celestial sphere which we are going to look at is the rational horizon. So the circle which we have drawn on the right side of the screen represents the rational horizon of the observer. And that is why the name given to it as rational horizon diagram, because it is made on the plane of the rational horizon of the observer. Now you see we have this north point on the rational horizon. Now as per our sign convention, we show this north point on top of our rational horizon diagram. It matches up with our charts also. We have the north direction represented upwards. So here also in the rational horizon diagram, we represent the north direction up. Now exactly opposite to this north direction on the other side, you will have the south point. And if you go 90 degrees towards the right side of north, you will have the east point. And if you go 90 degrees towards left side of the north point, you will have the west point. So let us mark off these points in our rational horizon diagram. We have the north point here. If you go to the right side by 90 degrees, you will reach to the east point. So you see represented by E in our diagram. And if you go opposite to the north point, exactly opposite to where the north point is, exactly opposite to it, you will have the south point represented by S in our rational horizon diagram. And if you go 90 degrees to the left of north, you will have the west point represented by W here. So all these 4 points, N, E, S, W, represented on the plane of the rational horizon. Now you see, going from north up to the north celestial pole, from the north celestial pole going up to the zenith, up to Q point and up to S point. This is going to look like a straight line joining the N and S points. So if you have a look at this from top, it is going to look as a straight line joining the N and S points. So let's see it here. It is going to appear as a straight line joining the N and S points. Similarly, if you draw a vertical circle which will pass from the zenith and pass from the west point. This vertical circle passing from the zenith and the west point, and also a vertical circle passing from the zenith and the east point. So going from east up to the zenith and coming back to the west point will also look like a straight line when you look at it from top. So you see, this is the W to E vertical circle line, which we visualized in the celestial sphere. And exactly in the center, you will have this Z point. When you look from top, the circumference will be the rational horizon, and this Z point, that is the zenith of the observer, will be exactly in the center. So let us show this Z point exactly in the center here. You have the Z point here at the center. Now from Z, if you move towards the south point, from Z moving toward the south point, once you cover an arc equal to the latitude, you reach up to point Q. So let's mark off this Q point in our rational horizon diagram. So from the zenith, when you move towards the S point and you move a distance equal to the latitude, you reach up to the Q point here. So from the zenith towards the south point, we moved an arc or distance equal to the latitude, we reached at Q point. So this Q point represents the Q point here in this diagram. Now, if you look carefully,
So the Q point ZQ is the north latitude of.
from the Q point, if you join up the W point, W to Q, and moving further Q to E. This particular arc, E point to Q point to W point, represents the equinoctial. So we can also show the equinoctial in our rational horizon diagram now. You have the W point here, you have the Q point here, and you have the E point here. So joining W to Q to E will give us the equinoctial. So let us do that. So you see W joined with Q joined with E gives us the equinoctial. So this WQE represents the equinoctial in our rational horizon diagram. This WQE you can see here in the celestial sphere diagram. This is point W going up to point Q, going up to point E. Only this part of the rational horizon will be visible to you. If you go beyond W on this side, or you go beyond E on this side, this is going to fall in the far side of the celestial sphere, which will not be visible to us. So this will not be visible to us. So that's why you only see half of the equinoctial, which is visible to you as WQE in our rational horizon diagram. Now let's proceed ahead. Let's come back to the Z point. From the Z point, if you go towards N point, towards the north point is here. So from Z, if you move towards the north point, equal to a distance which is your colat or 90 minus latitude, you will reach at the north celestial pole. So let us show this in our diagram now. We start off from the Z point, we move towards the north point, and we move a distance equal to 90 minus latitude or our colat. The point where we arrive is the north celestial pole. It is represented by P. So let's mark this as P here. You can see the north celestial pole shown in our rational horizon diagram. Let's mark off the arc P to Z also. So this is marked in yellow, exactly same as was marked in the celestial sphere diagram. So you see P to Z was marked as yellow, and it has been marked as yellow in the rational horizon diagram as well. This is equal to 90 minus latitude or equal to the colat. Now let's take our attention to celestial sphere diagram. From the Z point, if you draw a vertical circle passing through the body is here, that is star X. So from the zenith, if you draw a vertical circle passing from the body, going up to the rational horizon to point H and going up to the nadir, this is the vertical circle passing from the body. Now, if you look from top, this vertical circle is also going to look like a straight line. And how will this look? From the zenith, you see this particular dotted line. This is how this vertical circle is going to appear. The point where this vertical circle touches the rational horizon, you see the vertical circle from Z going up to X touches the rational horizon at point H. This point H is going to be this particular point here. From the zenith going up to the rational horizon, this is the H point. Again, somewhere in between the Z and H points, you will have the celestial body, that is the star, which is represented as X here. So let's mark the celestial body also now in our rational horizon diagram. So somewhere between Z and H, we will have the celestial body shown here in the rational horizon diagram, represented by X. You can see the celestial body here. Now you can see H to X is the true altitude of the body. So concentrate on the celestial sphere diagram. You see X to H highlighted in the maroon color. You have the true altitude of the body. The same true altitude is represented H to X in the rational horizon diagram. So let's mark it with maroon color, highlight it with maroon color here also in the rational horizon diagram. Now going back to the celestial sphere diagram, you see Z to X. This is the true zenith distance of the body, which is 90 minus true altitude. So let's show it here. Z to X. Let's highlight it also with the green color. You see Z to X is the true zenith distance of the body, and it is equal to 90 minus true altitude. Another important thing in the rational horizon diagram, you see the zenith is at the center of the rational horizon plane diagram, and the circumference which you see of this particular diagram is the rational horizon of the observer. Now we know every point on the rational horizon is 90 degrees away from the zenith. So this indirectly tells us that the radius of this particular diagram is 90 degrees. That means from Z, if you go to the rational horizon in any direction, it will be a 90-degree arc. So from Z, if you move towards H, Z to H is total 90 degrees. H to X was the true altitude of the body. That tells us Z to X, that is the green highlighted arc, will be equal to 90 minus true altitude. You can compare it with the celestial sphere diagram also. Z to H, zenith to horizon, was 90 degrees. H to X was the true altitude of the body, and Z to X is equal to the true zenith distance, which is 90 minus true altitude. So we have two sides of the PZX triangle now plotted in our diagram. Let's move on to the third side now, that is P to X. So this third side, which is P to X, going further to the south celestial pole, is the celestial meridian passing through our star. So we have to basically draw the celestial meridian of the star. So pole to X. So let's come back to the rational horizon diagram. This is the pole, and this is the celestial body, the star X. And we have to draw the celestial meridian now. So let's draw it. This celestial meridian is going to appear like this. This is how the celestial meridian is going to appear. So you see, passing from the pole, going further up to point X, and eventually going up to the rational horizon. This represents the celestial meridian of the body. Now the celestial meridian of the body cuts the WQE line. WQE line is the equinoctial at point D. Now you can look at it in the celestial sphere also. Celestial meridian from the pole going up to the body X goes up to the equinoctial at this particular point. So this point here is the D point referred to in our rational horizon diagram. This is the D point in the celestial sphere diagram, and it is referring to this D point on the rational horizon diagram. Going further from D, at this point, it crosses the rational horizon. And if you see here, going further from D, at it reaches this particular point, it will cross the rational horizon and go on the far side. So we have the celestial meridian of the body drawn now. Now let's mark off on this celestial meridian. From the equinoctial up to the body, D to X, this basically represents the declination of the body. How much north or how much south of the equinoctial a particular body is what is its declination. So the arc of the celestial meridian contained between the equinoctial and the center of the body is the declination of the body. So dx is the declination. You can correlate it in the celestial sphere diagram also. D point on the equinoctial, X point the celestial body, D to X is the declination. Now coming back to D point in the rational horizon diagram, we know from the equinoctial, that is D point, to the pole, that is P point, is always 90 degrees. Every point on equinoctial is 90 degrees away from the pole. So D to P or P to D is 90 degrees. D to X is the declination. That tells us that P to X will be 90 minus declination. The arc which is highlighted in maroon color now, it will be 90 minus declination, and it is the polar distance of the body. You can correlate it to the celestial sphere diagram also. You see, D to X was the declination, X to P is the polar distance, which is 90 minus declination. So you can see now all the three sides of the PZX triangle shown in the rational horizon plane. So as you can appreciate looking at both these diagrams, that diagram made on the plane of the rational horizon is much simpler and easier to make. And you will be able to make it in much lesser time as compared to the celestial sphere diagram on the left hand side. So this is the reason why we use the rational horizon diagram so diversely, so randomly to solve the celestial navigation based problems. Your doubts now, beta. Go ahead with your doubts.
So in this case, Pn will be equal to the latitude, correct?
Ask again, beta.
Pn will be equal to zq, which is equal to the latitude, correct?
That's correct, beta. Pn is the elevation of the pole. It will be equal
ZQ
to the
is
latitude of the
the
observer.
ZQ is the north latitude, right?
Okay, copied, sir.
That's right. ZQ is the north latitude, and P will also be equal to ZQ, which is the latitude.
Okay, sir. Thank you.
सर इस
बोलो बेटा.
सर ये जो आपने ट्रू एल्टीट्यूड का जो इसमें डायग्राम में जो आपका 2D डायग्राम में है एच एक्स है सर
Right.
एक्चुअली एल्टीट्यूड मींस बॉडीज हाउ मच अबव और बिलो फ्रॉम द रेशनल होराइजन करेक्ट सर
That's correct, beta. That's right.
ये डायग्राम में अगर थोड़ा सा हमें और क्लियरिटी मिल पाती बिकॉज ये एच एक्स ट्रू एल्टीट्यूड almost sir it is clear but little bit if more clarification regarding this true altitude from the diagram because it's not look like a body is um, above from the horizon
Okay.
or below from the horizon.
ओके बेटा. ओके. इसको ऐसे समझने की कोशिश करो. जो ये राइट साइड की डायग्राम है बेटा,
Yes,
ये
sir.
3D डायग्राम है. 3D डायग्राम, और इसमें जो Z पॉइंट है ना, वो हमें देखने में तो जहाँ पे स्क्रीन है वहीं लग रहा है, लेकिन वो स्क्रीन के बाहर है, वो आपकी तरफ है.
Yes, sir.
एंड वो सबसे हाईएस्ट पॉइंट है, वो 90 डिग्री का पॉइंट है. जो Z पॉइंट
Yes,
है
sir.
उसका 90 डिग्री एल्टीट्यूड है. तो अगर आप कहीं पर भी हॉराइजन पे हो तो आपका एल्टीट्यूड 0 डिग्री है. जैसे जैसे आप Z की तरफ आते हो आपका एल्टीट्यूड बढ़ता है. जब आप Z पे पहुंच जाते हो तो एल्टीट्यूड 90 डिग्रीज हो जाता है. तो अब देखो H2X, अब समझ में आ रहा है कि हम हॉराइजन से जेनिथ की तरफ जा रहे हैं, हमारा
Yes, sir.
एल्टीट्यूड बढ़ रहा है.
Hmm.
H2X इज अवर एल्टीट्यूड नाउ.
Yes, sir.
राइट बेटा? और डाउट्स
Yes,
बताओ.
बाकी तो सर बहुत अच्छा आपने एक्सप्लेन किया सर और ये फर्स्ट टाइम ऐसा पूरा क्लियरिटी दिया है और ये पीजेड एक्सट्रेंगल पे बहुत सारे क्वेश्चंस थे जो स्टक हो रहे थे बट आई थिंक व्हेन आई गो फॉर नेक्स्ट टाइम इट विल बी 100% all the things should be clear sir one thing
राइट.
more regarding this sir there are some condition where when the azimuth will be means in during when we are going to solve this pjx triangle one angle should be 90 here I can assume only the x is moving part so only which conditions uh, this angle z will be 90 sir and
वी विल
you
सी बेटा, वी विल सी. आई विल टेल यू, वी विल डू एग्जांपल्स, उसमें हम देखेंगे एंगल Z90 कब बनता है. वी विल सी, डोंट वरी.
क्योंकि पी पी पॉइंट भी फिक्स हो गया और जेड भी फिक्स हो गया ये और दे आर नॉट मूविंग ओनली द एक्स इज मूविंग only means
राइट.
body is moving so when it will be come to rational horizon then it will be 90 or when it come on the equinoctial then it will
डोंट
be
वरी,
90
डोंट वरी. मैं आपको 90 डिग्री वाला एक एग्जांपल प्रैक्टिकली सॉल्व करके दिखा दूंगा.
yes sir
ओके.
thank you very
और
much
ये
sir
this diagram which you are seeing beta, basically one, you will not find it in any of the books. This will not be there.
yes
And
sir
in none of the books you have this explanation being done how celestial sphere is represented in a rational horizon diagram. That's number one. And number two, if you have understood this concept, this is the master key to unlock all the PZX questions.
यस सर, आई
So,
रिमेम्बर आपने बोला था कि ये आप एक्सप्लेन कर देंगे, उसके बाद आपकी सारी जो पीडीएफ एक्स की प्रॉब्लम है वो सॉल्व हो जाएगी, एंड दैट इज
exactly,
ऑलरेडी डन सर, थैंक यू वेरी मच सर।
exactly. अब बेटा थोड़ा सा और एक्सप्लेन करने दो, मुझे दो एंगल्स आपको बताने हैं. So let me explain you those angles also. Give me a minute.
Sir, rational
बोलो
horizon
बेटा.
का definition, sir, please.
Beta, a rational horizon is a great circle on the celestial sphere, every point on which is 90 degree away from the zenith as well as the nadir of the observer.
Okay, sir.
Getting
Thank
clear,
you.
beta?
Yes, sir. Thank you.
Okay, all right. So let me show you a couple of more things in this diagram. Now we have seen all the three sides of the spherical triangle PZX. Now going a little further in the PZX triangle, let's now have a look at the angles. We first concentrate our attention on angle P, angle papa of this PZX triangle. Now this angle papa, if you look carefully, is the angle at the pole contained between celestial meridian of the observer. Celestial meridian of the observer is PZQS, and the celestial meridian passing through the body. Celestial meridian passing through the body is PXD. It is represented by this maroon color arc in the diagram. Now this is the definition of LHA, local R angle. Angle at the pole contained between celestial meridian of the observer and the celestial meridian passing through the celestial body measured westwards. You can see from the observer's meridian, we are measuring this angle in a westerly direction. The left side in the diagram is the westerly direction. So this angle P is the LHA, local R angle of the body. Now let's have a look at angle Z of this triangle. That is Papa Zulu X-ray, the blue color angle which you see in the diagram. Now this is the angle between the celestial meridian of the observer, which is PZQS, and the vertical circle passing through the body. The vertical circle passing through the body is ZXH. So this blue color angle basically tells us that this celestial body is so many degrees west of the north direction. If you start from the north direction and you go so degrees to the west, you will reach to the direction where the body is. So this angle basically is the azimuth of the body. In this particular case, this is the quadrantal azimuth of the body. North so many degrees west is the direction where the celestial body lies. The third angle in the triangle, that is angle X, it is the angle at the celestial body between the celestial meridian passing through the body and the vertical circle. This angle is usually not required in the PZX triangle solution, and we do not need to usually calculate it. Now, maximum number of or most of the questions which are asked to us in principles of navigation are based on the concept of this PZX triangle. We have seen that this PZX triangle is a spherical triangle. All three sides are great circle. This is made on the celestial sphere. Now in this spherical triangle, we have identified 5 parts. The 3 sides of the spherical triangle, angle Papa and angle Zulu. These 5 parts have been identified. Now the concept or fundamental behind these principles of navigation questions or questions based on the rational horizon is that out of these 5 parts, some of the parts are provided to us in the question. The data in the question gives us the value of some of these parts, and the remaining parts are to be calculated. So we use our knowledge of spherical trigonometry, we use the cosine formula or the Napier rule, whichever is applicable, and using the available parts, applying these two formulas, we find the unknown parts, the parts which are required by us in the question. So this is the concept of solving the rational horizon based questions.
Sir, can you explain one more time this azimuth, sir?
Okay, beta. Azimuth is basically the angle at the zenith contained between celestial meridian of the observer and the vertical circle passing through the body.
Okay, sir.
Okay.
So एक बार LHA की और definition एक बार ये R
Okay, beta. Okay. LHA local R angle is the angle at the pole contained between celestial meridian of the observer and the celestial meridian passing through the body measured westwards.
Yeah, okay. Sir.
Okay.
The angle at what to be called?
Ask once again, beta.
So the angle at the X, how to be described?
Okay. X angle does not have any name, beta. It is basically the angle at the celestial body between the celestial meridian of the body and the vertical circle. Okay. But it is not defined, it is not required also in our calculations. So that's why no particular name is given to it.
Okay, sir. Thank you.
Great, beta. Very good. So, any more doubts in this? Have you understood this? Excellent, beta. Great. Very good. So, I'm closing down. This topic is complete now. I'm closing down the presentation. Okay, excellent. So, that was the target for today, beta. And now we will move on to our questions on part C of our paper. These are question number 7, 8, and 9. Most of them are based on the rational horizon diagram, and some are other than those. So we will now go into these part C questions. For now, I'm stopping it here for today, beta. I'm stopping it here. And tomorrow's lecture, we will continue further with question number 7, 8, and 9. First topic which we'll be doing is star suitable for sight. That's question number 7. Right, beta? Clear?
Clear, sir.
Yes, sir.
Okay, great, beta. Great. So meditate on this diagram today and tomorrow we move on to number 7. Okay, then, beta. We call it off for today, and I'll see
Yes,
you
sir.
tomorrow.
Thank you,
Bye
sir.
bye.
Good night.
Bye bye. Thanks. Good night, beta.
Excuse me, sir.
Go
Excuse me,
ahead.
sir.
Go ahead.
Sir, I have a doubt in the assignment what you gave question number 3, sir.
Question number 3.
Yes, sir.
Okay.
A small part
Question.
of it. Number 3, in the last solution, just given without calculation.
Yes.
So we are taking a triangle and solving it. Can you please explain which is this triangle part, sir? The rest all is clear.
Okay. All right. Just give me a minute. I'll show you. Just a minute, beta. Okay, all right. Number 3. Okay. Now, number 3, beta, they basically ask you to find out the intercept. So we have obtained the intercept and we have obtained the azimuth also. Azimuth is also obtained. Direction of PL is obtained. Now they are asking us that find out if the site was worked out using long by Cron, what would be the observed longitude which you are getting. Okay. The easiest way of doing this would be you plot the intercept site. See, this is the dr latitude, dr longitude. This is the dr latitude. The azimuth is known to us and we can plot the intercept. This will be the ITP point and the PL can be plotted, right beta?
Yes, sir.
Now once you plot the PL, you will see that this PL will intersect the dr latitude at this particular point. That is point Bravo.
Yes, correct, sir.
Okay. And if you now remember the long by Cron method, in long by Cron method, basically we find out the longitude where the PL is cutting the dr lat. You see, reference point is the dr latitude, observed longitude, and the PL passes from there. So basically, long by Cron gives us the longitude of that point where the PL crosses the dr latitude, right, beta?
Yes, sir.
So if we had used the long by Cron method, we would have obtained point Bravo, right?
Okay, the position line where it cuts the DR lat becomes the observed long, correct?
Yes, that is correct, beta. That's correct. So now basically we have to find out the longitude of point Bravo. Now it can be found out in two ways. One is the simplest way. You can find out the departure from your plot. You can measure it here, find out the departure from your plot, convert it to D long straight away using the departure D long formula. That's one way. Right, beta? This is
By
one
graph,
method.
correct, sir. We can directly plot it on the graph and so that we can get departure and
You
convert to
can,
D long.
you can do that. You can do that. Now, what is done here is the calculation method. He has not measured it from the plot. What he has done it, he has made this triangle. I'll zoom in and show you. He has made this triangle beta basically. Let's remove the markings. He's made this triangle. And in this triangle, this particular triangle, Oscar, Alpha, Bravo. And in this triangle, he knows the side Oscar to Alpha is the intercept. This is the intercept. This is known to us. Right? And he also knows this angle Oscar, Alpha, Oscar, Bravo. This can be obtained from the azimuth of the body. This, I think, comes to 7.2 degrees. So this angle is also known. So using trigonometry, you can easily find out by using trigonometry what is the length of Oscar to Bravo. So you can basically calculate by trigonometry the departure. This Oscar to Bravo is basically the hypotenuse and Oscar to alpha is the base. So cos of this angle, cos theta is equal to base upon hypotenuse. Using that, you can calculate the departure. So without plotting, the departure can be obtained. This is what he has done in this calculation. You can do it this way also. Both ways are perfectly all right.
Okay, sir. Understood, sir.
Okay. Okay.
Sir, and
Great.
one more doubt, sir.
Go ahead.
Sir, in question number 8,
Okay. Number 8. All right.
yeah, question number 8 directly come to last part, sir. They've directly taken the sextant altitude. How did it get the sextant altitude of Meridional Pass without calculations? From GMT, they have
Okay.
taken the sextant altitude of Meridional Pass. Yes,
Okay.
this part, sir.
Let me see the question, beta. Give me a minute. Let me see the question also. Give me a minute. Number 8. Okay, let's see number 8 now, side by side. Number 8 says on 30th November 1992, the back angle observation of sun gave a sextant altitude of this much when chronometer showed this much. Find the PL and position through which it passes. Okay, so he has first corrected the altitude. He has got the long by chron. Observed longitude is obtained. Okay, all right. And the position through which it passes. If the vessel sailed on 125 till Meridian Passage that day, run 30 miles, find the altitude to be okay. All right, beta. So you are basically asking about the second part. Okay. Now the second part
Correct,
is
sir. They're
beta
asking the
basically
sextant altitude of Meridian Pass.
right. This is known as computation of altitude beta. So what we do in these questions is we calculate our dr latitude, right? We calculate our dr latitude. This EP latitude is what is calculated. Okay, it is same as what we obtained earlier beta. See, we obtained it earlier here na, EP latitude, and from this EP latitude we go backwards and we find out the sextant altitude. We go reverse. Okay,
Okay, so the calculation should be done from VP latitude to the sextant altitude because it was from sextant
exactly.
altitude to DP EP lat. So I thought that they got a sextant altitude before getting EP lat. Yes,
No. It is a reverse. There is no arrow put here. That's why the doubt. You have to basically start from EP lat and go upwards like this. What you do, beta, in the PRACNAP book, there is a chapter on computation of altitudes. Okay. Just go to that chapter. In that, you have the first solved example where they have computed the sextant meridian altitude of the sun. Just have a look at that solved example. You will understand.
Okay, sir.
Okay. If there's still any doubt, let me know in tomorrow.
Okay, sir. Okay, understood. Thank you, sir.
Okay, beta. Great. Okay. All right.
सर the figures ग्रेट सर्कल के फिगर सर कुछ कभी कभी कंफ्यूज कर जाता हूँ तो मुझे आंसर प्रॉब्लम आ जाती है तो फिगर्स थोड़ा सा एक नॉर्मल तो कभी कभी कंफ्यूज कर जाता हूँ सर
In great circle sailing, beta.
यस सर ग्रेट सर्कल सिंग सर
Okay, beta. I'll open up the whiteboard. Give
Yeah.
me that question where doubt is
Yes, sir.
coming in. Okay.
Yes, sir. Yes, sir. Yes, I'm here.
So let me open up the whiteboard. Let's see. Okay. Tell me, beta. What is the latitude, longitudes? What is the question?
Initial sir 42 degree 53 minute south and longitude 147 degree 20 minutes east.
40 to 53 south. I'm just taking the degrees to keep it simple. And longitude is
Long 147 sir. 147
147
degree. Yeah. East.
east. Very good. And we are going
And
to
final sir 52 degrees south
okay.
and longitude sir 72 degree west.
022
And 072 sir 072.
072
West.
072 west.
West.
Okay. Now, beta, the first doubt which comes in this question is, are we going in the easterly direction or westerly direction? ये देखना है हमें. Okay.
Yes, sir.
So how will we see that? उसके लिए हमें D long find out करना पड़ेगा. Now,
Yes,
how
sir.
do you find the D long? The longitudes are of opposite names. So to find the D long, we will have to add both these longitudes.
Yes, sir.
Right? We will have to add them. And since we are going from east to west, the naming will be west And when you add them, you get 9, 1 and 2. Right, beta? This is the D long
Yes,
which
sir.
is coming.
Hmm.
Now this D long is more than 180 degrees. Whenever this is more than 180, you have to subtract it from 360.
Yes, sir.
Right, beta? So when you subtract it from 360, it comes to
139.
141. Right?
Yes.
And you also have to change the name. So it goes from west to east. So your D long is 141 degrees east.
Yes, sir.
Up to here is clear, beta?
Yes, please, sir.
So now the making of the diagram is very, very simple. You are moving 40 to south to 50 to south. That means you are moving in the south direction. And the D long tells us you are moving in the easterly direction. Right? And
Yes.
both these positions are in the southern hemisphere. So we will take the south pole. So I will draw a course in the southeasterly direction like this. Southeasterly direction. I will make pole and I will draw my initial and final positions in this way. This is my starting position A. This is my destination B. This is the pole and I'm going in the southeasterly direction. Latitude is going southwards. As far as longitude is concerned, we are moving eastwards. This is how the diagram will be.
से यही डायरेक्शन से 52 डिग्री नॉर्थ ईस्ट रहेगा सर, तो इसमें उसमें क्या चेंजिंग है सर? 52 डिग्री नॉर्थ.
If the latitude instead of south is north.
Yes, sir.
Okay. So if this is the case, you will be going not in the southeast direction, but northeast direction.
Northeast direction. So always it depends on longitude, sir. Longitude I have to see.
That's correct, beta. Look at the D long. The direction of the D long tells you in which direction the ship is going.
Yes.
Okay, beta.
Yes, sir. Yes.
Okay. Great, beta. Very good.
Thank you.
Okay. All right. Good, beta. So let's stop it here for today, right?
Yes, sir.
Okay, beta. Great then. Bye bye for today. See you tomorrow.
Yes, sir. Good night, sir.
Good night.